So Algebra 1, this is 9.2, solving quadratic equations by graphing. So you have to use what we did in 9.1, which is graph the quadratic, but we're going to look for very specific places that it's going to be solved. Now when we say solve in a quadratic, we're talking about this guy. Right? Where does the quadratic equal 0? Well, here's the thing. Normally, when we go to graph it, the 0 is not there. 0 is not here. It's gone. It's equal to y. That means that the y is the one that's equal to 0. And if I was to graph a quadratic, there's my U shape. Where is y equal to 0? Y equals 0 is a line, isn't it? What kind of line is that? It's a horizontal line right here. It's the x-axis. The x-axis all have y equals 0, right? So, what we're doing when we're solving, we're looking for x-intercepts. We're looking for our x-intercepts. So all you are going to do is graph the equation and look for these guys. Now obviously there's actually going to be 3 different cases. On top of the fact that this could open up or open down as a quadratic. Another case, guys, there's 2 solutions for this one. If your quadratic went like this, now there's only one solution if it's just touching once. Or your quadratic could entirely miss the x-axis and there would be no solution to that one. Do you see how it's not even touching the x-axis? That's no solutions. So there are 3 cases for quadratics. So let's get to graphing. So let's graph this using all of our techniques that we've done before. So I'm looking at this. Look at A. A is negative, so that means it opens down, right? Because of A right here. We need to find the line of symmetry, our LOS, that uses that little equation. What was that equation again? Negative B over 2A. What's B? What is B?
Negative 3x.
It's negative 3.
3.
And so the opposite of negative 3 is?
Positive.
It's going to be positive. Over 2 times A. Negative 1. Negative and negative makes a positive. Whoops. Over a negative 2. So we know the x value of our vertex is going to be at negative 1.5 or negative 3/2. Because we have a line of symmetry here at negative 1.5. So our vertex is at negative 3/2, comma, something. How do we find that something? How do you find the something? How do you find the something? We take the negative 3/2 and plug it back in for x in the original equations. So it's a negative of negative 3 halves squared minus 3 times negative 3 halves plus 18. So, since we're probably not too fond of fractions, I could change that to a negative 1.5 and then just use my calculator and figure it out. If you're using order of operations, you have to square the fraction first, here, and then make it negative. So when you square it, it's going to become positive. What's a positive, or what's a 3 halves squared as a decimal? I do believe 2.25. I mean, anybody going to back that up? Check that on their calculator?
Yeah, back it up. It's confirmed.
And then in the middle, it's a negative times negative, which makes a positive. What's 3 times 3?
9.
Divide that by 2. 4.5 plus an 18. So what's negative 2.25 plus 4.5 plus 18? And we get 20.25. So if anything, actually, I'm going to go back to here. I'll change this to decimals because we're a little bit more familiar with that. And this becomes a negative 1.5 comma 20.25. Y-intercept should also be in here because that's an easy one. The y-intercepts, always plug a 0 in and you get a number out. But when you plug 0 in for x, they're gone, and you're left with 18. So those are the things, if you can find those things, then we're going to be fine. We're going to be able to find the solutions. Now guys, graphing's not very accurate. All of us in this room could graph these things, even these, and still come up with a different looking graph. So graphing's not the best method, but it's still good to kind of give us an estimate of where things are. So let's take this and start to graph it. I'm going to go by 2's, so I'm going to put a little 2 on the bottom there. I'll still go by 1's on the bottom because it stays all pretty close there. Okay, so the graph is going to look a little bit different than if I had them all by 2's or going by 1's. 0, 18, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Oops. There is 0, 18. I have at negative 1.5 a line of symmetry. So I should have it there. But that's also where my vertex is on, right? And it's at negative 1.5, 20.25. Well, that means it's just above that 20 mark. And that seems to be all I'm given. Well, what did we do last time when we were graphing all of these? We found these points and then we made a t-chart. So, let's make that t-chart. So this is going to follow exactly what you had to do last time. It's just that we're adding one more component to it. Here's the thing, guys. I'm going to put that vertex in the middle. And this is what I hinted at last time. Because there's a line of symmetry at the vertex, if you move in each direction the same amount, the y values will be the same. Look at this. If I put in 0, and 0 should be on the middle, or the positive, going to positive. I like to go down here. When I'm going down in the t-chart, it goes positives. And that ends up being at 18. Now, if I want to back up going the other direction, but I want to keep this distance the same. From negative 1.5 to 0, how far did I go? No. How far in the x direction did I go from negative 1.5 to 0? How big of a step did I take? I took a 1.5 step, right? That means I'm going to take a 1.5 step in the other direction. And what happens if I start at negative 1.5 and I take a 1.5 step backwards?
You're at 0.
No, I'm not. I'm already at 0.
Negative 2.5.
No, not negative 2.5. What's 1.5 plus 1.5?
3.
It's 3, so it ends up being at negative 3. Well, guess what? That value will be the same for y, because they are symmetric. So at negative 3, now if I go to my graph, 1, 2, 3, it's the same. And then from here, I'm going to take steps back and forwards nicely. Like, I'm going to go to 1, because 1's really easy to put in, right? Go back to your original equation. What's 1 squared? 1. And then I'm going to make a negative. So that would be, I'm going to have to put it someplace here so I can show my work. That would be negative 1. And then I'm going to subtract, what's negative 3 times 1?
Negative 3.
So I'm going to subtract 3 and then add 18. That's negative 4 plus 18. That ends up being 14. But guess what? Negative 4 is also going to be 14. So I could graph those now. 2, 4, 6, 8, 10, 10, 12, 14. So at 1, it's at 14. And all the way over here at 1, 2, 3, 4 is also. Is that starting to make a nice looking parabola?
Yes.
I'm going to stop here, and I'm just going to draw it in. This is why it becomes a game of maybe possibly getting things wrong. The room for error on these problems comes to the fact that to solve it, I need to know where does it cross the x-axis. Well, guess what? On my graph, they cross at this point and that point. One of them looks kind of nice, the other one doesn't look so nice. On your graphs, I'm pretty sure they're not the exact same as mine. So everyone in this room could have slightly different answers, but there are 2 of them. Because we know that it opens down and the vertex is above the x-axis. So we know there are 2 answers. My answer, one of them is 1, 2, 3, 4, 5, 6, is at negative 6, 0. And the other one is at 1, 2, 2, and 2.6, 0. It looks like about 2 2/3. About 2/3 of the way through. Now, how do I know if I'm right? How do I know if I did things right here? I would take those negative 6 and 2.6 and plug it into our original equation. I am not going to force you to keep doing this until you get the right answer. I want to say, can you give me an estimate? Because if these are not the right answer, we at least know that the real answer is not going to be negative 100. Because this is nowhere near negative 100. Could the real answer be something like negative 5 or even negative 7? I think so. Or somewhere in between. But it's definitely not going to be a 0 because it doesn't go through 0. It doesn't look like it is. First of all, it can't go through 0 because it has a y-intercept at 18. But you at least know those types of things by looking at your graph. So let's just quickly just check the negative 6 one because it's a nice one. If I put negative 6 in and I square it, I get positive 36. Squaring 6 times negative 6 times negative 6 is a positive 36, but then I have to make it negative because the negative's on the outside. So that's a negative 36 And then you come up here and you say negative 3 times negative 6. 3 times 6?
18.
18. Negative negative makes a?
Positive.
So it's positive 18. And I have to add 18 at the end of that. Wait a minute. 18 plus 18 is?
That's so silly.
It's 18 plus 18 is 36.
Oh.
And 36 plus its negative will equal 0. So actually, guys, I was right. This is one of my answers. Yes. Now, I don't know if that will work, but you guys can test it. If it doesn't work, that's fine. Just state 2.6 is not correct, but negative 6 was. You're done. I'm not asking you to fix it.